Testing.
Spelled at, but like
Testing.
at gmail.com.
Testing. Being loud voice. Cool. Okay, sorry about that. So, for the purposes of the stream, we're going to cover MongoDB and NoSQL databases today. Not going to do the whole thing again. So thank you guys for coming, and let's get started. So, as usual, I'm not an expert. I have not written a book on this. I'm just sharing the knowledge that I have with you. That knowledge has been useful for me, and I hope it can be useful for you too. I put this on everything because I'm paranoid, and I don't want people to be like, Beege, you told me, the thing you told me is 6 months old. It's like, come on, man. So, make sure to check stuff, test, experiment, be a good computer scientist, and experiment and observe things yourself. Why did that not work? Okay. So today, we have a lot to cover. We're going to, as mentioned, go over what are NoSQL or NoSQL databases. For purposes of ease of speech, I'm going to say NoSQL, just because that's easier for me to say. It is SQL, structured query language. We'll go over types of NoSQL databases. We'll go over the difference between relational database management systems and NoSQL. And we'll end the lecture portion with when to use NoSQL databases. Okay? And that'll be the first half. And for the second half, I actually have a GitHub repository prepared for you guys already that you can clone down. And you can set up a MongoDB instance using Docker, and we can go through it together. Okay? So we'll go over how does MongoDB work. We'll go over some data modeling in MongoDB because it is completely different from an RDBMS. And then we'll go over queries and aggregations in MongoDB because that's a little bit tricky. We'll also cover inserts and updates, but they're not too difficult. And then we'll end with a couple of MongoDB tips and tricks. Now, I kept the content of this a little bit light because I expect a lot of questions, especially because if you do have a relational database background, this is just not, it took me a long time to really switch my thinking, okay? So those of you who don't know relational databases, you might actually have an easier time, but we'll see how it goes. And as mentioned before we started the recording, I'll do a quick explanation of SQL databases, relational databases, just so you have something to compare against. So first off, actually, let's not do that yet. For the relational side of things, if you've ever used Microsoft Excel or Google Sheets or whatever, you're a little bit familiar with the structure of relational databases already. You can think of a relational database as divided into tables, where each table is like a sheet in a spreadsheet. It has rows and it has columns. Your columns are predefined. So you say, this table, this sheet, is going to have an ID, a name, an age, employment start date, title, team, all this kind of stuff if we're doing some kind of HR thing. And then you can have multiple tables, each with their own sets of columns, and each table represents a thing. That could be employees, that could be departments, that could be transactions, that could be orders, that could be inventory, whatever. And then you basically connect these tables through different relationships between fields. So for example, let's say you have employees, you have departments, right? An employee belongs to a department, right? Maybe many employees belong to one department, right? So what you would do is, in the employee table, you would have a department ID, and in the department table, you'd have an ID, and if an employee belongs to some department, you would store that department's ID in the employee table for that employee. And then you can say, okay, this employee belongs to that department. Done. That is relational databases in a very, very compressed nutshell, okay? NoSQL databases work completely differently, especially because relational databases, there's many different types, but they all use the same structured query language, SQL. And this is why NoSQL databases are called NoSQL databases, because they usually don't use SQL, or if they do use SQL, it's not the primary way of using it. For example, MongoDB, which we're going to talk about today, has a SQL interface, but you normally you don't want to use it. It's a bad idea. It doesn't work too great, in my opinion. But anyway, let's get started. So what are NoSQL databases? So people call them either non-SQL, as in they don't have a SQL interface at all, or not only SQL. Now, one thing to keep in mind, SQL is only an interface. It is just a way to interact with the storage system, okay? How things can be stored can be completely different. But SQL was designed to work with a specific way of storing things, okay? So NoSQL databases have a different way of storing things. This whole table thing with rows and columns, it's different in NoSQL databases. They have similar ideas, but it works differently. So a NoSQL database is basically any non-traditional, non-relational database. That should say non-traditional. I'll fix it or non-relational, but I'll fix that after this. Now, it can, as I mentioned, it can still have a SQL or SQL-like interface, but some of the key attributes is that they're highly scalable, specifically horizontally scalable, and they usually apply to specific use cases. If you're not as comfortable with the different types of scalability, there's vertical scalability and horizontal scalability. Vertical scalability is you get a bigger server. Horizontal scalability is you add more servers, okay? These days, generally, we prefer horizontal scalability because it's easier to add a new server than to basically take down the existing server, upgrade it, and then turn it back on, at which point we have taken on downtime because we had to shut down the server, okay? So this is what I mean when I say NoSQL databases are highly scalable. So questions so far? I'm surprised because if the answer to what is a NoSQL database is, it's just not a SQL database, that doesn't really answer the question. Because then, is a CSV file a database? A NoSQL database? Kind of. Like, by the strictest definition. In practice, no. But you could argue that a CSV file or JSON file is a NoSQL database. But that's not what we're talking about today. There are specific types of NoSQL databases. I've listed here a few of those types, at least the more popular types, and examples of each one. I only did one example because it's been a busy week. For example, there are document stores, usually document being a JSON document. So that's MongoDB, which we're going to cover today. There are also key value stores. Key value being just like, here's a key, here's a value. That's it. No more complex data structure than that, which is very, very fast, but doesn't allow a whole lot of flexibility. And hence, that's where Redis fills in. So that's why Redis is great for acting as a cache or for acting as session storage, this kind of stuff. Now, you can always store more complex data in a value or even in a key, but natively it's mostly a key value store. There are graph databases where with a relational model you have all these different specific types of relationships and ways you need to structure the data to fit those relationships. But with a graph database, you have just two types of things. You have kind of a node, which basically acts like a row if compared to a relational database, and then you have an edge, which connects to another node, right? And so you end up creating a graph, right? Now we're talking about a computer science graph, not like a chart graph, okay? So that's a graph database. There are also time series databases, which are a little bit more similar to relational databases, except your primary key, the way that you index data by, is by a timestamp, usually. And they're very good at going over data in time. So for example, logging systems, they're often just fancy time series databases, right? And then there are wide column databases, which, man, I don't even know how to explain that. They're complicated. You can have predefined columns, but you can also add columns on the fly, and your columns can have columns inside them, and then you can group columns. They're complicated. If you want to go learn about that stuff, read it on your own. It's too much for me to explain today. Okay? So this is what we mean when we say NoSQL databases. It's basically not a relational database, and it covers a lot. So if someone's like, oh, I'm a NoSQL expert, you can be like, no, you're not. No one's going to be an expert in all of these systems, okay? But if they say, I'm great with document storage, you're like, okay, I know what that is. That is a specific type of database with a specific type of access model with a specific type of storage mechanism, this kind of thing. To be an expert in all of these would take many, many, many years, and not much time to do much else. So, yeah. Questions about this so far?
I missed the explanation about graph databases. How do they work on a high level?
So, for purposes of the stream, how do graph databases work at a high level? You basically have two key data structures. You have a node, and then you have an edge.
Oh, so it's like an actual graph.
It's an actual graph. It's just a graph.
Okay, it's just the graph serialized
Sure.
onto disk with like the database features like constraints and stuff like that.
Yep. Now you can predefine different types of edges and different types of nodes. I haven't used them in detail. I've spent like maybe 2 hours with a graph database, so my knowledge is not very deep. But they're really useful for things like social networks, or things like, movie databases where you have actors and directors and all this kind of stuff in all these different movies, where the relationships themselves hold value. That's where graph databases become more valuable. With relational databases, the value is just more showing that the entities are connected, not necessarily how they're connected, and not necessarily seeing like the span of the connections themselves. Whereas graph databases, you can see how each thing is connected, and then it kind of emphasizes the connections themselves. So basically, the relationships are more important in graph databases.
Thank you.
Yeah. Other questions? Cool. Also, for those of you who have not attended one of our workshops yet, I usually wait an uncomfortable amount of time after asking if there are questions, because usually people need time to think of the question, and then they need to be like, yeah, okay, I'll ask it. So please be patient. All right, so now that we know kind of what types of NoSQL databases there are, we know a little bit about relational databases, how do we compare these things? So the key similarities are that they both persist data. I mean, and even that's not 100%, because you can run Redis in a way where the data doesn't persist, but and then they usually have indexes. Is anyone not familiar with indexes? Even our people that didn't know SQL stuff are familiar with indexes? Cool, okay. Huh? So, I'm sorry, I can't hear you.
Does index mean, does it go beyond that basic 1, 2, 3, 4, 5?
Okay, I'll explain indexes. So, kind of. So, in indexes, when usually in some type of database system, for each entity, for each thing that you're storing, you have some kind of identifier, right? So, which could be 1, 2, 3, or it could be a UID or whatever. It could be a timestamp in time series databases, right? But you're not going to search for everything by ID, right? Again, let's go back to the HR system example where you have employees and departments, right? Are you going to search for an employee by their ID? Probably not. Like, I don't even know my own employee ID at my company, right? You'll search for employees by name. So what you do is, in database systems, they have this idea of an index, where you have the table data, where everything is sorted by its ID, but then you also have kind of a separate storage, where you store them by the field that you want to search by. So then you store it by name, and then that basically references a row in the original table. So if you've ever looked at like the index of a book, like in the back of a book, where it has like all the special terms and then the page number, it's the same thing.
So it's like a classroom.
Kind of. Yeah, so they use a B-tree data structure, which I forget if you actually hash the things. I haven't gone that deep in a while, but maybe. But yeah, does that answer your question then? Cool. Any other questions about indexes and stuff? Because they do exist in most NoSQL systems, so you do want to know them. Cool. All right. So, but then what are things that are unique to NoSQL? Things that you can't really do in SQL? Well, first off, non-tabular storage. And what do we mean by tabular storage? We mean like a table, so having a fixed set of columns. Okay? most of these systems do not have a fixed set of columns, except for kind of wide column storage, but complicated. But the data structure is much more flexible, which is good and bad, which we'll see in a little bit. They also usually provide a variety of query methods. So in SQL databases, you have your SQL interface. That's pretty much it. In many of the NoSQL databases, you have a variety of different query methods, and you have usually different ways to go about finding data. For example, if we look at a graph database, let's say you want to find the connection between this node and that node. Do you want to do a breadth first search, or do you want to do a depth first search or something, right? I mean, maybe I actually don't really know how they work. Maybe that's not how you search at all, but it's just an idea. Whereas in SQL databases, like you store the relationship in data, and then you join based on some column. That's it, right? That is the one way to access data. These other systems have all different ways of doing this. As I mentioned earlier, NoSQL is usually horizontally scalable. And what that ends up creating is NoSQL systems follow something called the CAP theorem, as opposed to ACID. We're getting into some heavy theory now, and I'm going to spend a couple of minutes on this. Okay? What's up?
You might probably already explain this, but can you explain what CAP theorem is?
Yeah, I'm going to do that now. Yeah. So CAP theorem applies only to distributed systems. Why does this matter for NoSQL? Well, if your system is horizontally scalable, that means it's distributed. You have distributed onto multiple computers. So CAP theorem applies to distributed systems. It means that CAP stands for consistent, available, oh no. Partition tolerance, thank you. Thank you, Tom, my savior, every time. And so these three things, consistency, availability, and partition tolerance, you cannot have all three in a distributed system. It is not possible, according to CAP theorem. So this means you have to give up one of these, right? Either you can't do partitioning properly, as I understood, or it can't always be available all the time, or it can't be immediately consistent, right? Whereas ACID is atomic, consistent, isolated, and durable, right? Atomic being, if you kind of make some changes, those changes happen as a single operation, and you won't have a partial change, right? So if you try to change a whole table, either the whole table gets changed or nothing gets changed, right? So it's an atomic change. It's a single, indivisible unit. Consistent is basically if you make a change, that change will be there, or no. If you make a change from this side and you look at it from this side, you'll get the same thing. I forgot the I already. What did I say? Isolated. Yeah, isolation. Thank you. Where basically, if I change this record, it's not going to affect any other record, right? There's not going to be side effects. And then durability is, if I shut it down, it still works. Or if I shut it down and turn it back on again, it still works. And if I make a change, that change will persist. Okay? Now, CAP theorem says you can't be ACID, right? You can't have all of these things, so you have to choose two. And that's where stuff gets a little bit funky. We're not going to go super deep into this today, but it is important to understand when you are making your decision, because you can't have all three things, okay, when you're making the decision between relational databases and non-relational databases, okay? So this is just a very brief overview on CAP theorem. I do recommend reading a little bit more about it, because that will help you make a decision as to what kind of system to use, okay? Did everyone at least kind of get that? What's up? Correction, welcome.
CAP theorem, from what I know, is not something separate. They are not mutually exclusive to ACID, right? And relational databases, they also belong to CAP as well. It's just C and A usually. Mongo can be, for example, A and P, or A and C, I guess. It depends on the configuration. I'm not sure why you word it as opposed to. Is it something that's different? Or,
So Tom is offering a correction/question, if I understand correctly, saying that ACID and CAP are not necessarily mutually exclusive, and that you can have kind of a little bit of both. But, yeah?
Yeah, so for relational databases, you have consistency and availability, and they also are ACID usually, right?
Right. But the thing with relational databases is that they're not distributed.
They could be distributed, why not?
Because, well, that's why CAP theorem is a thing, right? So if your writes are distributed, that's when stuff gets funky. Now, systems like Percona for MySQL, Postgres, I don't remember, MySQL, have kind of figured this out, but they have like a lot of constraints around kind of locking mechanisms, and I think they do a lot of heavy partitioning, as I recall correctly. It's been a while, but that's been my understanding. So it's kind of hard to do both with a distributed system. Now, there are we're just gonna go in the weeds. So on the relational database side of things, the traditional way of doing it is you have a single database that you can write to, right? And then you replicate to a whole bunch of copies that you can only read from, okay? Because otherwise you run into the CAP theorem, okay? So when you have this style of database, one writer, many readers, you kind of avoid the CAP theorem, and it's only partially distributed, right? But once you have multiple nodes that can be write, then you run into your consistency issues, okay? But you can do sharding, you can do partitioning, this kind of stuff to kind of make it work. But then if your read comes into the wrong node, then it has to get updated, and it's a bunch of timing issues. Yeah.
So how I know it works, so you can have a situation in relational databases where you have multiple master nodes, and they all accept writes. But the biggest challenge is how you do the transactions.
Right.
This is what I see is the biggest advantage of having relational versus NoSQL, because the locking mechanism in relational will have to coordinate somehow. How do you commit a transaction? In NoSQL, you very often have a different mechanism that doesn't rely on the presence of other nodes, which makes it fast. But you have trade-off of NoSQL not being C, which is consistent. So,
right.
And consistency in this case, as far as I remember, means that all clients can read the same state from the database no matter what. In NoSQL, you might have
some read delay or write delay, something like that.
Basically, inconsistent. You can read inconsistent state.
Yeah.
So, say one node writes something to node A, the other one to node B, and the client reads of them, and it turns out that the data from node A hasn't arrived yet, which ends up being inconsistent with the like real-time state.
Yeah. So I'm going to try to rephrase or try to mimic what you said for the recording purposes. If I get it wrong, please correct me. So Tom was saying that with relational database systems, they kind of solve the multi-write problem via transaction and locking mechanisms, right?
It is possible. It's uncommon.
It's possible, but not common. And to my understanding, it's also limited in how many nodes you can do it with, because the latency increases the more nodes you add. And so you can kind of have ACID and CAP with relational databases using these kinds of mechanisms like Percona and whatever. But with NoSQL systems, they kind of let the consistency bit slide a little bit, where they're eventually consistent. Which means that, let's say you have like 20 nodes, okay? And a write comes into this one. But then immediately after that write comes in, someone tries to read from this one. How do they see this newly written data? Well, in an eventually consistent system, they don't. There's a delay, there's a lag. And you just kind of decide to accept that eventual consistency. Eventually that data will get replicated to all of the nodes. Now, in relational databases, they have locking mechanisms across the nodes to do this, which is why you don't want to do it with too many nodes. But with NoSQL systems, they just say that's okay. Is that a good summary?
Perfect.
Cool. And thank you for the corrections. Thank you for the specificity. I never actually studied Percona in detail. Like, I know it's done, but I know it has to be limited, and I don't understand exactly how it works, so I was hoping to just kind of skim over it, but I can't get stuff by you. So yeah, basically the more you distribute, the more cap theorem becomes a problem. If your distribution is very small, like in the case of a multi-write relational system, you can kind of just slip by the cap theorem, okay? But read about the cap theorem. It's interesting stuff. I can't spend too much more time on it. But any other questions about it?
I just don't understand a single thing with the, why is it if you have more nodes, it's a problem with locking mechanisms?
Because basically communication takes time,
Yeah.
right? So the longer you lock,
Yeah.
the longer that data can't be changed by another system, and you end up getting a cascading effect of like queuing transactions.
Okay.
Yeah. Yeah, good question though. And that's why with the eventually consistent systems, you accept the write on this node,
Yeah.
and then you just distribute the data later.
I get it.
Yeah. Cool. Other questions? All right. So I think we're still good on time. So with all this, when do you use NoSQL databases? When you need super high scale, right? That's a no-brainer. But are you going to need super high scale? Probably not. Like, so when I worked at Riot Games, like big giant company, they still used relational databases, and it worked. So you only need like super huge scale as like a sole justification for NoSQL databases. So that's one thing. But if you have a rapidly changing schema, NoSQL databases lend themselves a little bit more nicely to that. A lot of people are like, oh, it's a NoSQL database. I can change the schema whenever I want. Everything is cool. No, God, no. I have lived that pain. There is still a lot of care that needs to be taken when you change a schema, even in a relational database. But it is still easier than a relational database, okay? So that's a thing. If you're working with semi-structured data, NoSQL databases can be quite good. When your data is kind of a different shape, like a lot of records don't have certain values, or a lot of records have different types of values. NoSQL databases handle that a little bit better. Or if you need very high speed, like very, very high speed, even if it's not a large scale, NoSQL databases, if designed properly, can 100% be faster than relational databases. But again, it's very rare that you'll need that level of speed. Okay? And then there's always the needs fitting to that specific NoSQL database, right? So if you're working with purely time series data, don't use a relational database. Use a time series database, right? These kinds of things. Or if you're doing like social networks or something, a graph database makes a lot of sense because it was specifically designed to fit that problem. Okay? So these kinds of things. Personally, in my recommendation, focus more on the specific use cases. If the data you're working with doesn't lend itself well to relationships, then start considering NoSQL. Okay? So I want to be very clear. SQL databases cover most use cases. Okay? So don't be like, I would go use NoSQL for everything. No, don't do that. They are a very, very, very useful tool, but in specific cases. Okay? I just want to make that very clear because I tried to hop on the NoSQL train a little early and started doing stuff, and I was like, why? Later, I learned why, solving specific types of problems. Like always in computer science, use the right tool for the right problem. Okay? So use them when they fit your need particularly well. Okay? What's up?
So, can you give us a good example of what semi-structured data?
DICOM. But I need to give an answer that's useful for people not working in medical technology.
Okay, that was a very good summary.
Spill it.
What, the thing I told him? Oh, geez. Oh, God. Okay. Oh, no.
Spill it.
I'm going to try to make it quick.
It's the source of my headache and many others.
So at the company we work at with a lot of medical imaging data. And within this medical imaging domain, there's a specific file format called DICOM, D-I-C-O-M. It's something like digital image communications, something, I don't know. I don't know the acronym. But it has a very, very strictly defined structure, which are like, oh, structured data. But no.
Whatever they want.
Yeah, no. Almost no one actually follows the structure, and it's just a file, right? You can do whatever you want with a file. There is nesting to the data structure. There are arrays within the data structure. Those are also variable within the structure, and the specification accounts for that. And there are many fields that are required that no one fills in. Lots of this fun stuff. Great data quality all the time. Everything is 100% where it should be 100% of the time. Guaranteed. In case you're reading a transcript of this, I'm being very sarcastic. But this is a case of semi-structured data, where the structure is not very rigid. The structure is not very predictable. So that's usually what I mean by semi-structured data. Does that make sense? What's up?
So is the data with missing fields, or is that because this sounds like a normalization problem or sanitization problem? In theory, sanitized data, so it's according to your own internal schema, and that would work well with either NoSQL or SQL, right?
Right. So his comment was, the problem I described with DICOM sounds more like a data sanitization problem and a normalization problem. And you are correct. And we actually we have kind of multiple stages that the data goes through, and in some stages we keep it in a semi-structured way, and in some stages we do refine it, normalize it, and put it in a proper structured data storage. But there are cases where the shape of the data is less important, and we'll just grab data when it's available, whatever format it's in, and that lends itself well to the semi-structured use case. And there are cases where we need very rigid structured data to do very complex and detailed analysis, and that's where having it structured, having it properly normalized, having it properly sanitized becomes more useful. Does that answer your question and make sense? Cool. So.
I think you're talking of CSVs, XMLs, RDBMS.
Yep, those are also semi-structured data. For the stream, Lawrence, right? Yeah, Lawrence mentioned also CSVs, XML, JSON. These are all examples of semi-structured data. That's kind of the classic example. Actually, not even classic, just standard. So thank you. Other questions before we move onward to MongoDB specifically? Yep, what's up?
Can you give an example for rapidly changing schema? Does it happen? I mean, if it happens, is it serious, or is it something that somebody's made mistake and they have this kind of rapidly changing schema, and it's a monkey patching way of solving the database problem?
So if I paraphrase your problem, when I'm talking about rapidly changing schemas, am I talking about something that's an actual constraint of the business problem, or is it because of poor business practices?
Yeah.
It could be either. If it's because of poor business practices, you're going to get less, the benefit's not going to be as clear, right? Because your business practices are poor, right? If it's because the nature of the data changes a lot, that's going to fit pretty nicely, actually. So, for example, let's say that, let's say you're doing e-commerce stuff, right? Maybe different store managers are going to want to add all sorts of different metadata, right? And you want to store all that metadata, but you need it to be in some kind of structure, maybe a semi-structured way, and you still need it to be fast. You still need to be able to serve it, parse it, all this kind of stuff. That is great for something like MongoDB. That is like the perfect use case. Whereas if you try to do that in SQL, you can or in a relational database, you can totally do it, but you're going to hate your life. So way back when, a previous company I worked at, we used Jira. We used the on-premise Jira. And as soon as something's on your infrastructure, You can do anything you want with it. It may not be a good idea, but you can. So I dove into the Jira database. And they basically used a relational database to do kind of semi-structured work. And it worked. Like, Jira's a pretty decent product. Key emphasis on decent. But that database schema is a damn nightmare. Because they accomplish a semi-structured format where users can define however they want to structure their Jira issues in a structured database. It's doable. It just sucks. What's up?
An interesting reason behind it could be that they need transactions, right? Because Jira is inherently transactional problem, so they want to commit and make sure that data is there and everybody can read the same state. If you had NoSQL there, you'd have to do some syncing and worry about it.
So Tom's suggestion was that, hey, maybe that was because they needed the transactional nature of a relational database. And I would agree, but I'm going to offer two counter arguments. One, this is before NoSQL databases were popular. And two, it's not so much scale was the problem. And therefore, if you did not fully distributed or only a little bit distributed, many NoSQL systems still support transactions. So at the scale that they were working at, or the scale of an on-premise deployment of Jira, transactions would probably be okay, I would say. For cloud Jira, absolutely not. But yeah. Because like MongoDB, for example, has transactions. You can do it. It's not always a great idea. It implies that you have a problem with your data schema, but you can do it.
I just missed the earlier part, but when you mean transaction, you mean like a transaction as in like a certain block of like a query insert operation, and if one fails, you roll back everything.
Yeah.
Right?
Yeah.
Okay.
Yeah, that's what I mean by transaction. So for the stream, to clarify what we mean when we say transaction, it is multiple change operations, multiple writes, whether they're inserts, updates, deletes, whatever, performed in a way where if any part of it fails, the whole thing didn't happen. Or if everything succeeds, it all happens at once. This is what we mean when we say transaction. Cool. Any other questions before we dive into MongoDB specifically? Yeah.
Is there a slide when not to use NoSQL database?
Is there a time when not to use NoSQL databases?
Yeah, when not to use.
Yeah, when your data is heavily dependent on relationships, but it doesn't take the nature of a graph. Which is like most of the time. So like an HR database, for example, you're not going to need to track the relationships between different employees. That's not the purpose of an HR database, right? You need to know which employees belong to which departments. Maybe you need to know salaries. Maybe you need to know which managers of which department, this kind of stuff. That can be accomplished with very simple relationships. Relational database. Most data relies on relationships, right? So let's say you're doing a video game, right? You have a player, like a human person, who has an account, who has a character, who might be in a level of the game. These all things need to be related somehow, right? Relational database. Basically, the only value to data is the way in which the data relates to other things. If I tell you 100, what the hell does that mean? It's a number. If I tell you 100 people, you're like, okay, more useful, but 100 people what? 100 people at Lunit. Okay, there are 100 people at Lunit. I have developed the relationship between those 100 people, those 100 records in a database maybe, and a location Lunit, which is some other entity, which could be a record in another table. Okay? Most of software is modeling the real world, and a lot of the real world is about how things interact with each other. If you want to go super big brain with this stuff, space and time. Time does not exist without space. Things moving in space. That creates time, right? Everything is about relationships because motion is relative to each other. This is a fundamental fact of our reality as we understand it, and it persists into computer science. I'm sorry if that was really nerdy, but yeah. So
this might be more practical, and just wanted to just ask this question. Let's say, for example, a particular set of data grows very rapidly, meaning that compared to ordinary data, like static data, like employees and whatnot, like this kind of data grows like very, very quickly. So like in one day you might have like 1 million inserts or more.
Sure.
Or like, let's say like 10 million inserts.
Sure.
Let's make it extreme.
Mm.
And let's say, for example, you do have to like query it like on an hourly basis to
Mm.
retrieve statistics.
Mm.
Would that be a good use case for NoSQL if it grows that rapidly, but you need to extract some sort of data on a periodic basis?
So again for the stream, so the question was, let's say that you have some data that you're storing, and one entity out of all the stuff that you're storing grows incredibly rapidly as compared to everything else. And you need to be able to query that maybe hourly or something,
Yeah, to
right?
perform some aggregations.
To perform some kind of aggregation.
Or would you use a relational database?
I want to give a straight answer, but it still depends. So we're going to get real in the weeds here. I'll have to go a little bit faster later, but it's okay. So, no, well, it's tricky. Yeah, well, what's up, Tom?
Answer this question.
Yeah, go for it.
So I think what you're looking for is something like columnar-oriented databases, which or OLAP cubes, basically BI, business intelligence. So these kind of databases or Microsoft analysis services, they offer a solution that relies on a data store that's specially tailored to generating reports and generating like series reports from terabytes of data in seconds. Like in 1 second, it is capable of multidimensionally querying a cube, OLAP cube, and giving you the result set, and very complicated queries. So yes, this is NoSQL, and I think it's used the purpose.
So I'm guessing NoSQL, though SQL plus like some MapReduce function would get the job done.
You may not even need MapReduce.
So
Go ahead.
that's how complicated it is, but OLAP cube is like the pinnacle of report generation.
Mm.
Okay.
So Tom suggested using an OLAP system, an online analytics processing system. He specifically cited Microsoft SSAS, SQL Server Analytics Services, or server, I don't know, S. But basically that allows you to do something called dimensional analysis with your data, where you pump a whole bunch of data into it and you super normalize it. And it allows you to generate large reports very quickly because it's based on the values of different dimensions, and you're only picking out exactly what you need because it's a hyper-normalized system. Yeah, that's probably the perfect application of an OLAP-style database. Now, OLAP can be done in a relational system, but it could also be done in a NoSQL system. I've seen it mostly in mostly in SQL-based systems, but maybe there's something new that I don't know about. But I think it fits either that very well, or you could use a NoSQL system, because if you're only querying it hourly, and maybe if you provide some cutoff before the hour, an eventually consistent system should be just fine. In which case, NoSQL is fine.
So what I'm worried about is maybe if the data is partitioned, it might be fine. But like I was just worrying if there's a large amount of writes and there's indexing operations done. Indexing usually does come out at a trade-off,
Yep.
because if you do indexing, that means that generally your writes are going to be more expensive because you're adding more metadata into each rows.
Yep.
So I was wondering how that would come to play. And the only thing I have to think of maybe is to partition the data so that each store that only has a limited amount of data, so that the queries are faster.
Yeah. So for the benefit of the stream, Jay's concern is that if you're very, very write-heavy, the indexes on your data are going to cause pain, because every time you add an index, that makes your writes take a little bit longer. So if you have a huge amount of writes to an index-heavy table, it's going to be super slow. Stuff is going to back up. You may end up with a crash, or you may end up with connections refused, all this kind of stuff. In that kind of situation, I would actually recommend just throwing a message queue in front,
Oh, okay.
just to queue stuff up.
Like Kafka or like Rabbit.
Yeah. But again, it depends on the nature of the system. Is it just like a batch processing thing? Then
Okay, good question.
just
Good
batch
point.
it,
Okay,
right?
good point.
But if it's like just users having to jump in all at the same time, that's when stuff gets a lot more complicated. So to really dive in and answer your question in detail, I need to understand the use case a lot better, and I don't want to spend any more time on it right now.
I'm satisfied already.
Okay, cool. But in any case, it's an interesting problem. Okay, so now, is everyone tired of listening to me talk? All right, liars. So how does MongoDB work? Let's do some hands-on stuff. Just a quick description of what MongoDB is before we get our hands dirty. First off, it's a JSON document store. Is anyone not familiar with JSON? Spectacular. That makes this way easier. So it's basically you say, hey, here's a collection of JSON documents, and then you put a whole bunch of JSON blobs in there. And at the simplest level of explanation, that's MongoDB. Now, ideally, the documents within a collection have a somewhat similar structure, and we'll cover that why in a minute. Why that is in a minute. But it's basically just storing JSON data, hence semi-structured. First, it is shardable. So you can do partitioning. So you can say, hey, these kinds of records go on this node, these kind of records go on that node, or tell it to automatically partition and distribute all this kind of stuff. So you can set up like 20 or 30 nodes. If you need that many nodes, I'm going to ask, what the hell are you building? That's crazy. But it is a thing. It also supports replication. Let's say you want to replicate for some read-only nodes. You can do that, much like the relational database systems. Again, like relational database systems, it is also indexable, but pretty much all NoSQL systems and SQL systems are. But the best use case that I have seen for it is when you have a low amount of writes and you have a high amount of reads. Okay? That's where MongoDB really, really, really shines. You can still do it in a high write system, but then you have to worry about your eventual consistency problems. Okay? But if your write speed is low, if your write throughput is low, and you need a boatload of reads, MongoDB, baby, is good stuff. Also, something that's going to be weird if you're coming from a relational database background, duplication is good. In relational world, that sounds like heresy, right? Like, don't you dare duplicate data, right? In MongoDB, you do not want to normalize. So relational systems, I don't get it. People keep telling me like, oh, I want to avoid joins in my relational database. I'm like, what is wrong with you? That's the point of a relational database. They're optimized to do joins. If your indexes are good, and as long as your filtering criteria makes sense with your data structure, like, they're meant to do joins. They're supposed to be fast. It's fine. Maybe your data model sucks. But in MongoDB and many of the NoSQL systems, joins are bad. Don't do joins. Do not do joins. One of the applications that my team works on now was made by some people who didn't have a software engineering background, who did not really study MongoDB in detail. They designed it like a relational database. We're doing a lot of joins. It sucks. You want to avoid that. Instead of joining data, duplicate data. And I'm going to show you examples of that in a minute. Okay? So any questions about kind of MongoDB at the high level? JSON storage, sharding, duplication. Yeah. Aggregates. Yeah. Aggregates with lookups suck. Because you basically lose, lookups being joins. Because you lose all of the benefits of an index. Once you do a lookup, everything, all of your index benefits, not are completely lost, but it's not great. Yeah, lookups are joins. Sorry. When we talk about MongoDB, if I mention lookup, I mean a join when you're talking in relational terms. They call it a lookup because that's literally what it is. It goes and looks up the data, it pulls it out, and then it's separate. Whereas a join, it does references on disk, creating a virtual table, or joins in a relational system. It basically finds the two matching records, basically records the reference in memory as a virtual table, and then pulls it all out at the end, only pulling what it needs. And so it can take advantage of all the indexes because it's all referential. Whereas with MongoDB, when you do a lookup, it just fetches the data in memory and then does stuff, which does not include the indexes. Not fast. Not fast. But yeah, sorry. But That said, I'm not saying MongoDB is bad. If you can design your data model in a way where you duplicate and nest data instead of needing to do joins or lookups, it is super fast. It's super easy. But we're going to cover what you have to consider about that in a moment. Any other questions?
I read a comment of MongoDB.
Mm.
They say they use JSON.
Yep. Okay. So the question was, he was reading about MongoDB and saw that they used BSON. BSON is basically a binary representation of JSON. So it has a structure similar to JSON, but it's stored in binary rather than text. This just allows faster reads and writes. That's all it is. Good question, though. Other questions? Or does that answer your question?
Sort of.
So you can just, like, I'm glossing over a lot of stuff, but you can just think of it like binary JSON, and it's just faster.
So it's based on data with 0 ones.
Sorry?
So it's based on data with 0, 1, 0, 1 JSON data.
Yeah. So basically what they do is they take the structure of JSON, they convert it to kind of an indexable binary format with all sorts of references and lookups, kind of almost like a file system, I would say. And so your references are easier rather than having to parse text, because parsing text is just slow. So they basically convert everything into a binary representation of things for faster. It's similar to like a hash versus like the raw value. Yeah. Other questions? All right, you ready to finally use your notebooks? All right, let's do this. So let's actually run a MongoDB instance on your computer. Go to that repository. I hope you can read it. I'll also share it in the Discord. If I can figure out how to use my computer here. Did I close it? Beege. What is wrong with you? Give me just a second to send the link in Discord. You might be typing it faster than I am. There we go.
Clone it.
Yeah, clone that down. Oh, I did oh no, I just opened. I'm losing my mind. Okay. So go ahead and clone this. Ideally, you have Docker installed already. Don't forget to turn on Docker Desktop if you don't have it set to auto on, which you shouldn't because it's really heavy. And then once it's up, it does take a few seconds to actually come up. And then you can visit localhost:8081 in your browser, and you will see something called Mongo Express. So go ahead and do this, and then I'll do it as well. If you run into issues, just hold on a second and watch me walk through it. But I don't want to walk through it now while people are looking at the screen. I imagine most of you are ignoring me right now to follow what's on screen. That's perfect. You're good. We know the two people who were paying attention. It's fine, though. I don't want you to pay attention right now. I'm really tempted to, like, say something inappropriate, but there's like a stream and a recording, so because I know no one's paying attention. Well, now more people are paying attention, but no dirty tricks for me today. And please give me a signal once you're finished. Fortunately, we're in Korea. Docker pull is pretty fast. Doing something like this in the US would be less fun. It looks like most people are heads down. Does anyone run into issues?
Right.
No
I
problems?
can start my Docker without control signs.
Oops.
What's the default username and password?
Yeah.
Oh, I'm sorry. Thank you.
I'll try root example, but that's for the database, not for the web interface.
Right. The default credentials for the web interface are, I think, admin pass.
I should
Try it. I'm not sure if it's admin pass or admin password.
Great. I'm in.
Example.
try. Yeah, pass. Yeah.
Admin pass. What's that?
Where was that defined?
I believe it shows up in. I don't remember where I found it. I don't remember if I saw it on the logs or if I went and looked up the Docker image. I think I just went and looked up the Docker image.
Yeah, I don't see it in the YAML for the composer.
No, it's just the default. I think it's on the Docker image.
The repository. Or?
Yeah. Man, I'm looking forward to chicken after this.
I am
Maybe we should move a like standing chair in here.
You want to sit down?
Oh, because I didn't have time to do the full setup. I have to stand here. Whereas if I was,
Do you want us to get you one of those chairs outside?
no, that's okay.
Yeah,
Um,
chair.
Yeah, something like that.
What was the password for you guys again?
Yeah, let me
Because
just.
my Wi-Fi is
Let me
slow.
just enter.
Online Wi-Fi must be slow.
Oh wait, shit, this is a German keyboard. I
Yes.
dealt with this today. Okay, wait, I dealt with this earlier today. There we go. I have so many German friends now.
No, it's fine. Oh, okay. Thank you.
Is this the right height then?
I don't know. We'll
It
find
didn't
out.
work.
It didn't work.
No.
Have you tried harder?
Or we can, if it's not the right height, then we can pull it a little bit.
Don't worry. It's not a big deal, man.
Put it on the stage.
Put it on the stage, yeah. And then pull that thing a little bit back. Right.
Okay, looks like it's working now. Okay, cool.
So you know much about NoSQL databases?
Not as much. I've only used MongoDB. That's like the only NoSQL database.
Oh.
Graphing database?
Yeah, good idea, Jay.
I don't know anything about graphing database.
I saw that they had like pathfinding. I was wondering if you could use it to like do some type of weird pathfinding for a growing city or something like that.
Probably could maybe. Like, I don't know. I never used it before, so.
Maybe you should figure it out and give us a session on graph databases. Which one? Oh, Neo4j? Yeah. Yeah. Yeah, that's the one I played with for a little bit too.
Yeah, they have several different versions of pathfinding that all for Neo4j.
That's pretty cool. All right, is anyone still working on the? Is anyone still working on this? Everyone got this going? Does anyone need help? Need help? Okay. Okay. Let me give you a hand real quick. Actually, here let me do it up here first, and then when we hit the part where it doesn't work for you, just wave at me. Okay. All right. So. Oh, okay. Yeah, no, this is why I didn't want to do a chair. Okay. It's fine. How do I do this now? Right. So, let me... Oh, God. There's so much. That's not the one. This is the one. That's the one. Yeah, okay. So, this is... Why didn't I do this before? This is way better. So, what we're going to do is... So, I already cloned down the repository. Everyone got to that part, right? Cool. So, now... we have a Docker Compose here, okay? This Docker Compose runs a MongoDB Docker container and then this Mongo Express Docker container. Mongo Express is just basically a Node.js Express server that is set up to connect to MongoDB. Has a little web interface, all that fancy stuff. So we do Docker, oh, typing is hard, Docker-compose up. Does a bunch of stuff. Now, normally you would see a bunch of Docker pull stuff, but because, oh, that's right, it's right here in the output, Will. You were asking earlier where it was, it's right here. Oh, and then it disappears because MongoDB does logging.
That's
Yeah.
It disappeared when I did the next step.
Gotcha.
It's in the Mongo Express documentation.
Gotcha. So then, if we pop over here, and we go to localhost :8081, I'm already logged in apparently. Right, because it's doing history stuff. Oh, I can't see the... Oh, they don't have a logout. That's cool. Well, anyway, you would get prompted to log in, admin pass, and then you should see something like this. Is everyone except for her able to see this? Everyone's here? Cool. All right, give me just a second to help her out. Yeah. Oh, you're still downloading the image?
It was way faster with the Wi-Fi from here.
But we're not on the Wi-Fi.
All right. Okay. Makes sense.
Gotta get a faster VPN.
Sometimes it sucks.
What are you using VPN? You're not doing something illegal, right?
No, I just want
He doesn't trust the name.
I just don't trust like Wi-Fi. Like if I'm in a coffee shop, I have to do the VPN.
Well, it's a password in Wi-Fi, so it's not like we can't read your data.
Yeah, I know they can do stuff, but it takes time to get into my stuff. So I have to keep routing into different IPs. In the process,
That's all right.
I like the security stuff, but I'm not in the security area. But cybersecurity will be nice.
I work in cybersecurity and I don't care.
You don't really care.
No.
It should be the case with the VPN area. Like, oh, VPN is even you may be having Raspberry Pi where you have your own like portable VPN.
I'll use a VPN to connect to important things, but
Yeah.
not a MongoDB Docker image.
Yes.
Yeah.
This is for Netflix.
I use
All right.
my VPN for work. So.
All right, so everyone's good? Everyone's good? Oh my god. Okay, we're gonna fix this. There we go. Ah, beautiful. Oh, that's way better. Okay. So everyone's here, except for catching up. Cool. All right, so, what was the plan? Crap, I don't remember the plan. That's right. So what we're gonna do, I kept using the example of an HR database. Of an HR database. That was weird. So we're going to do that. We're going to try to track employees and we're going to track departments. Okay? So let's, but first, let's figure out how MongoDB kind of is structured. So MongoDB has the idea of databases. Okay? There's the MongoDB database server, and then inside it, it has databases. Okay? A database is just a logical, kind of physical separation of data. Okay? So like if you're doing microservices, you'd have a different database per microservice or something, right? So we're going to create a database name. We're going to call it HR. Okay, so I'm just going to say HR up here. I'm going to click Create Database. Woo! That was easy, right?
We can all go home.
Okay, so everyone's got their HR database made? Cool. So now if you click View here, cool, I have an HR database. What is this delete me thing? Well, MongoDB does not let you make a database without a collection. So it just made a collection for us. And then we can make our own collections and all that. So let's go ahead. I mentioned earlier, a collection is a grouping of JSON documents. Okay? So you can think of a JSON document, or you can think of a collection as a type of thing that you want to track. Okay? So let's say we're doing an HR database. We want to track departments within a company. Okay? So let's make a departments collection. Okay? And then click Create Collection. Cool. We have our departments collection. Okay? So far so good? You like all the greens and blues here? Like, definitely made by a back-end developer, right? Not a designer in sight. But it works beautifully. All right. That shows you're a back-end guy. So now let's go ahead and create a document, new document. Okay? Now here's the thing. You see this underscore ID here. Okay? In MongoDB, this underscore ID is a special field. Okay? This uniquely identifies each document in MongoDB. Okay? They use something called an object ID. Okay? This is a BSON thing. All right? It's represented to users as just like, I think it's 16 or 32, probably 32 hexadecimal characters. Okay? But it's just a unique identifier for a document. Okay? So you can usually just leave that alone. That's the unique identifier. The database is going to generate it when it's ready. Okay? And then we're just going to make a new department. So this is just JSON. Okay? So if you know JSON, you know this. And their indentation on here is not right, so please just deal with it. But then we can add another field called name, and let's call it the IT department. Okay? Yep, all good? Is everyone with me? And then click save. Congratulations, you've inserted your first data into MongoDB. That was so hard, right? It's because it's a very contrived example. But you can see here now, this is a listing of all the documents in the database. This right here is the ID. I'm guessing that's 32. I'm not going to count it. But that's the BSON object ID. Okay? And then we have this name field here. Okay? So far so good? Cool. Let me come help you out. Yep. Yeah.
What VPN does your work make you use?
I don't know yet. I got a new contract this week.
Okay.
Yeah, so
Hopefully it's a good.
the last I've been at, the last project I've done, they just had like a internal one because they're security firms and they pretty much do their own hardware for like securing their other hardware like laptops and stuff.
Right.
So they even have like if you wanted to even use the laptop, you had to use like a card.
Wow, the
From
card-based
the-
authentication?
yes.
Oh, that's
Also,
awesome.
ever heard of Xena?
It's not that one.
Yeah.
That's kind of old though. Like,
Yeah.
Card-based is like.
It's Germany. It's Germany.
Okay. So,
Everything now they
They
do
needed
is
a
be
lot of
like-
okay.
You know, YubiKey?
Sorry, guys.
Yes.
Yeah, that was nice.
All right. So we've created our first document. Cool. This is totally useful, right? I can make a whole application off of this. Yeah, no problems, guys. No. But I just kind of wanted to show you, this is MongoDB. You have databases, and then collections, and then documents. Okay, and then the document is just JSON. Super simple so far, right? Everyone understands that much? All right, great. Let's go back to the presentation real quick. I think I need to drink some water, but I'll do it later. So let's get on. Before we start inserting a whole bunch of data into MongoDB, let's talk about data modeling. I have to stand. This is too weird. Like, I really appreciate the chair, but talking to people while sitting is super strange to me. Or doing this. So first off, a key thing with MongoDB, and this is what a lot of people miss, especially when they're thinking, oh, the schema's flexible, whatever. No. Before you lay out your data in MongoDB, you must know your access pattern. Okay? What do I mean by access pattern? I mean you have to know what kinds of queries you're going to make to the database. Okay? Because that is going to determine how you structure your data. Okay? Your data needs to be structured based on how you're going to pull the data out of the system. Okay? This is very, very, very different from relational databases. In relational databases, you model the data after the attributes of the entities, right? So I have a person has properties, a person has a relationship to a department, right? I don't care about how I'm going to pull out the data, right? I mean, I care for purposes of indexing, but that's it. And the indexing you do after you do all the entity definitions, right? That's normal relational database design. But with MongoDB, you have to think about, okay, I'm going to search for employees. Okay, how am I going to search for employees? I'm going to search by name. I'm not going to search by phone. I'm not going to search by address. I'm going to search for employees by department, right? That's a key thing. You want to know what employees are in a department, right? I'm going to pause on this point. I want you to remember that idea for a second, okay? We're going to come back to it. In MongoDB, you want to duplicate data as needed. Disk is cheap now. It is okay to duplicate data. We can duplicate things. It is not heresy, okay? We're not in relational world anymore. Duplication of data is okay. And you want to nest data appropriately, okay? So nesting being like taking one thing, putting it inside of another, putting inside of another, putting inside of another, and so on, okay? Nesting data is okay to a degree. You don't want to go too deep, but a couple of levels is fine. So, if I want to look up people by their department, I have a separate departments collection. Should I have an employees collection and look up to departments? No. Lookups are bad. Don't do lookups. Instead, what you do is, when you create that employee record, when you create that employee JSON, you copy some of the department data into there. Now for your relational people, you're going to be like, the hell is that? Right? You want to embed another entity's data in some entity? Yes, yes you do. This is what MongoDB is designed for. So you would, if I have, let's say Nadia, right? Backend engineer, right? Well, full stack, yeah, backend engineer. And I would basically embed the IT department in her document. So I would do, ID, name Nadia, department, new JSON object, and then the ID of the department, and then the name of that department. Okay? What's up?
Why is this not awkward?
Why is this not awkward? Because we've been in relational databases too long,
Okay.
right? Now, another reason why it might feel awkward. What if you change the name of the department? Now you have to go change the name of all those employees, right? Yes, you do. Okay. You have to do that. Totally fine. In MongoDB, that's okay. That's how we do it. There's a part of the relational database guy in me is like, oh, it feels so gross. I don't want to do that. Why do I have to go change the data in multiple places? I changed it in one place. I have to go change it again? Yes. Yes, you do. Because MongoDB is meant for really fast reads. So you want all the data grouped together. Okay? So to kind of push through this awkwardness, actually no, we'll do it later, right? Because I have a plan with that, and I don't want to mess up my example. But what's up?
So quick question. Say you want to update these employees, right?
Yeah.
Is MapReduce the solution? Because MapReduce works on all the nodes, so it will change the data quickly compared to updating records one by one.
I'm not sure.
I mean, how is this same? Right? Because it looks like you have to do loads of writes to change a small thing, right?
Then
Yeah.
the front end, like what you're querying in the front end is.
Yeah.
'Cause
So, but
most of the times in the back end with the Mongos, you have like a list of some sort that you map to. Like
Yeah.
in a JSON.
but the mapping, right? You don't want to do lookups.
What is MapReduce?
Oh God.
I can't
I'll
look
talk
it
to you
up.
afterwards.
Okay.
Yeah, I'm not going to teach MapReduce right now. The simple answer is easy, but a satisfying answer is longer.
I can look it up.
Yeah. So yeah, it's gross, it's weird, it sounds insane, but the focus with MongoDB is fast. Your writes can be a little bit slower. Your reads need to be fast. Because remember, MongoDB's ideal use case is low writes, high reads. Okay?
So an employee database is a terrible use of MongoDB.
Kind of. But you can do it. You can totally do it. And there are reasons why you would want to do it. We might get into them depending on time. Yeah. But yeah, Will was basically saying like an employee database is a terrible example for MongoDB. Actually, yeah, kind of. I probably should have come up with another example. I was in a hurry. I'm sorry. But you still can do it. It's just a little weird. Okay? Still totally doable. So then, as I kind of just described, you group your data based on reads. If you need that data if you need a certain piece of data when you read some document, include that data in the document. If you need to know the department of a user when you fetch that user, just put it in the document. Or if you need to search for users based on their department, put it in the document. Okay? Yeah?
Where's the flexibility, right? You have a business there, right? And business wants changes.
Yeah. So you change it.
I mean, how do you change it?
You just change it.
Database.
You just do a write operation.
All right.
Right? So in relational databases, we don't like updates. Right? We do updates only when necessary, because updates are scary and dangerous, right? And they incur cost penalties, right? In MongoDB, just do it, man. Just do it. Now, here's the thing. I'm sorry. I made a mistake. This example is not a good example. It does not show you the strengths of MongoDB, okay? MongoDB is great. This is a shit example. I'm sorry. Tom's right. This is insane for this use case. But I wanted to use something that everyone's familiar with. Everyone, is knowledgeable. Like, you work at a company, there's departments, all this kind of stuff. If I had had more time, I could have come up with a more fitting example. This week was really rough. So I'm sorry. It seems insane. I promise you, if you apply it to the right use case, it makes much more sense. But that said, you will still have duplicate data, and that is okay. So get a little bit comfortable with it. And then another thing is you want to avoid variable keys. Okay? So JSON is key value, right? Maybe the value is another object with more keys and values, but it's just all keys and values. You want your keys to be somewhat consistent within a collection. Okay? As much as you can. Okay? It doesn't have to be, hence why, it's semi-structured, right? You can mess around with stuff. That's totally fine. But if you can, try to avoid variable keys. And I'll show you a strategy for doing this in a little bit. Okay? The reason for that is indexing and searching. And you're going to see how aggregate queries work, and you're going to see why that's useful. So, right, it's next. So I'm not going to focus too much on inserts and updates because, they're really easy. They're, really easy. You just saw one. It's really easy. I'm going to focus more on getting data out because that's, the focus. So we have this find operation in MongoDB. Okay, find one, find many. That's it. And the way you find stuff is you submit a key, you submit a value. I expect this key to be this value. If it matches, give me the data. Okay? It's much more based on filters. In SQL, we do columns, target table, join, and then filters at the very end, right? We're thinking about what data do I want, how do I get to the data that I want, and then how do I filter it. In MongoDB, all the data you want should be in the document. So you just got to figure out which document you want. Okay? So it's a very different way of thinking about things. It's a little tricky to get used to. So the first thing when you will find is, what are my search criteria? What are my filters? In SQL, it would be, what is my where statement? Or more likely, series of where statements. So you do key value. So if I was searching for the IT department, I would do find, JSON, name, IT. And then I would search for all documents where the name key has the value IT. Done. Pretty simple, right? Now, there's a whole bunch of different functions. You can get really complicated with this. You can do and, or, not equal to, greater than equal to, less than equal to, in, if you want to have it be one of a set of values. You can do if a field exists, because it's JSON, right? You can just not have a key. Maybe you want to find a document where that key does exist or where that key does not exist. Gesundheit. Or maybe you want to do a text search using a regular expression. There's also a where, but it's different from SQL where. Don't get confused. Where is mostly used with nested arrays. There's also size, if you want to check the size of an array. There's also element match, where let's say, remember this is semi-structured. We can store arrays in our JSON. So let's say that you have let's say in the departments collection, I almost called it table, in the departments document, you have an array of members of the department, which makes sense. When you're looking up a department, you probably want to know who's in that department, so you include it in the document. And maybe you want to find maybe an employee who is senior level and has been at the company for more than 1 year, right? If you store that data in the department document, this element match function, operator, whatever, can help you search for each element of that array. So for each employee in that department document, it'll check that they meet the element match criteria, okay? If it didn't make sense, the documentation is pretty good. I just wanted to let you know that exists. What's up?
So the thing is that you have this set of questions to the database, and they have to be somehow, they have to correspond to your data structures, right?
Yep.
Which suggests that the structure is not very flexible, because it's usually, I mean, is it difficult to change in Mongo as well?
So here's the thing. Your structure of your JSON documents is not defined unless you define it. You can define constraints to say, hey, every document has to fit this structure. You don't always want to do that. There's no definition of that at the collection level. Generally, if you search for something that doesn't exist, it just doesn't match. So you can have two completely differently shaped JSON documents in the same collection. Totally fine. There are no constraints against that. From your application logic, that causes a nightmare. But, yeah, MongoDB is not as flexible as people make it sound, because your application still has to rely on your key value logic. If the data is not structured how you expect it, good luck. It's not magic. It can't magically figure out what fields you want. What's up, and then you next.
Correct me if I'm wrong. So when you want to use MongoDB, you have to consider all the questions you would potentially have to the database first.
Yes.
Later design it, and then it will work. The promise is that it will work very fast.
Yes.
Fast reads.
Yes. So to summarize what Tom wanted to confirm, he's like, you have to figure out how you want to access the data first, and then you model it, and then the result is you get high speed. Yes. So I would argue that MongoDB, the way that you're supposed to do things in MongoDB, is the right way to do things. Because when we build our software, we should build it from the perspective of the user. The perspective of the user defines how we access the data. And that should define our data model. I'm also still a little bit uncomfortable with how the data gets modeled actually, but in terms of the process of it, I think that's kind of ideal. Now, does it actually happen in the real world? But that's how things should work ideally, and if you're using MongoDB, you can kind of force that process a little bit. Does that make sense?
Makes sense, but I would mention change requests, because they cause trouble.
Yeah. So migrations in MongoDB are very important whenever you need to change your schema. Yeah. So you have to be careful with changes. What's up?
Right. I'm just curious. So, like with the key value search, if you just have key value search, it just looks up where's my key and then it finds the value, right? But if you have like functions like this and you have a really big collection, it checks every entry in that collection, or
Indexes. So MongoDB. So the question was, if everything has a different structure and you're looking for a specific key and a specific value, does it have to just check every document? In this way, it works very similar to relational databases.
Okay.
Your documents can be indexed.
Yeah.
You can apply indexes at the collection level. I hadn't mentioned that yet. Thank you. So if we go back, oops. Okay. If down at the bottom here, we have indexes. They're defined at the collection level, right? So we can define a new index, and we can say, thank you so much. I forgot to do this earlier because I didn't have notes for this part. We can say that we want an index on the name key, and then a positive one that is an ascending index, right? A negative one would be a descending index. Okay, so we do this, and now we have an index on the name field, and we can search for name quickly. Okay?
no, I understand.
Cool. Any other questions before we go forward?
The index is supposed to measure and the process searches backwards.
The index is written backwards. Yeah. So basically, if your data is how do I explain this without being? I could explain it the simple way incorrectly, but we'll get the general idea across. Or I can be correct, but make it more complicated. When you're constructing an index, if your index gets constructed in order, like let's say it's something in terms of time, adding to the end on an ascending index is easier, right? Because the way indexes are structured, adding stuff to the end is easier. Adding to the middle has a little bit more cost. So that's why the direction matters. Adding to the beginning has a whole bunch of cost, right? So that's why the order matters. But in a lot of cases, you can't really control how data gets inserted, so So.
Actually, for Mongo, if you do the process of inserting your indexes, it becomes a problem in the future because you can't track all of the indexes. So the best option would be each object of a schema is automated, like there's that automatic system process that happens when you create a schema. So the ID that is provided by Mongo is the best option for you to look up within a given collection. But if you create your own object, it's very tricky to look for that because you may forget how the naming convention that you used to do the whole process.
Oh, you're talking about an identifier.
Yeah, kind of. Yeah.
In this case, we're talking about indexes based on the fields you want to search on. So, for example, if you would search by name, right, then the order of the index doesn't really matter because you can't guarantee that only names later in the alphabet are going to get inserted. So in that case, the order of the index doesn't really matter, right? But if it's something like, it's okay. But if it's basically, if you can predict the way that new data will come in, then you want to control the other order. Otherwise, don't worry about it. But this is different from kind of IDs. IDs, the default underscore ID, don't mess with that. That is, like he's saying, the best way to order the data. That's the primary index if we were to compare it to relational systems. Yeah. Okay, time. So, we're getting tight. Any other questions before we move forward? Cool. I'm going to be less delayed when asking that because we're getting tighter on time. So you guys get the index part now. I should have made a note in here for the future. Anyway, now here's the thing. Let's say that you have a nested key, okay? So like let's say we have something like an employee document, right? They have a department key, right? And that department key is storing another object, which then has an ID and a name. So, but maybe I want to search for employees by the name of their department. But department is the original key, and then there's a sub-object that has a name key. How do I get to that? You just use a dot. Just like you were doing like normal JSON stuff. You would do the employee document dot department dot name. Or for your search, you would just do department dot name. That's it. And then, in addition to when you do finds, there's also something called a projection. A projection is which fields you want to pull out of the document. Because maybe for some queries, you don't want the departments. Maybe you just want the employee's name and phone number or something, right? You can say, in your projection layer, you can just say, give me the name field, give me the phone number field, done. And that'll speed up stuff too, because then you don't need to pull out the whole document and parse through all of it and all that. It's basically like the select statement of a SQL query, okay? But notice here how the find comes first and the projection comes later because of the way the data is structured differently, okay? Projection also supports functions, so you can do like math and stuff like that if you need, or you can do concatenate different fields or filter or rewrite or all this kind of stuff. Projection supports all of that. You can just look up the function docs for that, okay? All good on this so far? Cool. So, and then, give me a second. Yeah, okay. So after this, we're going to go back to the hands-on part. There's also aggregations. Let's say you're pulling out a whole bunch of documents and you want to do analysis. Maybe you want the count of users or the sum of the total cost of objects in your shopping cart or something, right? Or you want to see like the count of users among some field. Or maybe you want to filter for certain things and then aggregate and then split into two branches and You can do all this. one thing that's really cool, one of these functions called facet, or I'm sorry, one of these stages called facet actually allows you to kind of split your query into two different pipelines. So let's say, and this is, I was so happy when we figured out how to do this. Let's say you're writing an API, a REST API, and you're returning a list of resources from that REST API. But you also want to return the number of matches for the original query and return it as, to give like the total number of pages for pagination. Facet. Because what you can do is you can do your filter criteria for which documents to match, and then you can split your aggregation pipeline and have one be, just give me the documents that I want, and have the other one do, hey, do some aggregation to say, hey, what's the total number of pages? And then you can return all this stuff in one query. You can't do that in SQL. You have to do a union, or you have to do two queries. Actually, not even union quite works, but yeah. But anyway, aggregation pipelines, they are pipelines, right? So they have various stages. You have match, which is for the filtering. You have project, which is for picking out different things. You have bucket if you want to chop it up into slices. Add fields if you want to enrich some data. I mentioned facet. There's also unwind. Like let's say that, you got let's say you're searching for the department, you get the employees, but then you want each employee to be its own document. You can just split them up into their own documents. There's also group limit. There's a whole bunch of stuff. Aggregation pipelines in MongoDB are crazy. They're awesome. They're also really fun once you start to get an understanding of them. So definitely check those out. But for now, let's get back into, yes, that is the button I pressed. Okay, for now, let's get back into here, okay? So come back with me here. We're going to, awesome. Did I really not? Okay. Anyway, open up a new terminal. I have one open here, and do an npm install. Okay. I've already defined all the stuff you need to go here. So just do an npm install. It'll install the MongoDB driver, and it'll install .env just so that we can get configuration, and I don't have to walk you through that. Okay.
Is it fully mounted?
No. I wanted it to be blow upable.
Oh, okay.
Yeah.
Wait, then if
Oh.
npm install to work, then wouldn't that have to be we're accessing via the
No, the npm stuff is in your local project. It's not in a Docker container.
Oh, okay.
Yeah, I'm doing part in Docker, part not in Docker.
Oh, okay.
It's a little confusing, but it was the easiest way to do it.
Okay, thank you.
So I'm going to go through this code real quick, and then we're going to mess with it, okay? So here we have .env just to get our database configuration, this env file. This has all of our stuff to connect to MongoDB. You normally never want to commit your env file because that has all of your sensitive configurations, okay? But just because this is a demo, I just wanted to do it this way. I made a note, don't commit this in the future. And then we pull in so this is JavaScript, Node.js. You probably figured that out already. We're going to go ahead and pull in the MongoDB repository, or MongoDB library. And then we're going to make our connection string, okay? That's basically how we connect to MongoDB. And then, I was doing this. Normally you don't print your connection string because there's a password there.
Yeah.
But again, being careful. And then we connect, okay? So very simple. Import, connection string, connect. So far so good? Cool. So now, I have a whole bunch of debugging here. So then you want to tell MongoDB which database do you want to use. Okay? Also, damn it. Why did I change it? I'm sorry, guys, real quick. We got to make a change. In your env file, when I was doing this, I called the database test. That was a mistake. Change it to HR. Hit save. I'm sorry. Please make that change in the .env file. Okay? Everyone's got that? Cool.
The npm install side is all done.
Okay. So now, this one here, we get our departments collection, which we made in the UI, okay? So in MongoDB, you have to tell it what collection you're doing operations on, okay? Because a collection is like, a collection of documents. We need to tell it which documents we want to do stuff with, okay? So we grab our departments collection, and we can store the collection as an object. Okay? And then we can just say, hey, find departments that match my query. In this case, my query is just an empty object, which will just match everything. Okay, so I'm basically just saying, give me all the departments. All right? And then we iterate, that gives us back a cursor. So we're going to iterate through the cursor. We're going to await because it returns promises. And then we're going to print out each document. And then we're going to print done. Everyone good? All right, so now let's go ahead and run it. And you'll see it prints out our IT department. I ran this. Has everyone got this? Cool. All right. Now, that's boring, right? Let's do some more interesting stuff. We're going to do a little bit of data modeling. We're going to do a little bit of pulling out data. We're not going to do aggregations because we don't have enough time. But let me get my reference here. Okay, here we go. So, crap. Beege, you idiot. Maybe it'll work. Maybe it'll break. I don't know. We'll see. Okay, so, yeah, it'll be fine. So let's skip that part. So this is supposed to be an HR database, right? We want to track departments and employees. So let's go ahead and I want to show you guys how to insert in code. Okay, so before we do our run our find, let's go ahead and I didn't delete this example comment. Oh well. Let's go ahead and insert a new department. Okay, so what we can do is I want to store the department result, so I'm going to say insert department result. And then everything is a promise. MongoDB works very nicely with async await kind of things. And then we're going to, in our departments collection, we're going to insert 1. Okay? And, whoopsie. Okay. And for this insert 1, we're going to insert a new department called marketing. Okay? So far, so good?
No ID.
No ID. It will create an ID for us. Good question. Good? Cool. All right, so now that we've done that, we want that ID because we want to insert employees, right? And we need to be able to relate the employees to the marketing department, right? Now, just because I said relate doesn't mean we're doing a join. We're not doing joins. Joins are bad. So we're going to let's store our marketing ID. We're going to basically pull our result here, and then we're going to pull out the inserted ID, okay? This is very basic, but I'm just showing you this so you know it is possible. Okay, this is how you do things. Now you can also define the ID beforehand and insert it with an ID. And I'll show you that in a minute. And that's totally okay to do. All right? So far so good. Does this make sense to everyone? Cool. Now, I want to start tracking employees. Oh God, how do I turn this thing off? Damn it.
MetaBob extension.
Yeah, what is it called? MetaBob? Was that it? Yeah, I want to turn it off. Oh, I hate this thing so much. Like, it's really useful, but it's really intrusive. Maybe, well, I want to... Actually, wait, here we go. I'm sorry, guys. Give me just a second.
I'm going to disable it.
Yeah, I'm just going to disable it for now. It is a good thing. It's just not good while I'm doing a thing, while I'm doing a presentation. Okay. But I'm not going to like strongly endorse it or say anything bad against it. This is not an advertisement for or against Metabob. I kind of like it. I find it a bit intrusive. Mixed feelings. But anyway. So we have our marketing ID, right? And then we want to create an employees collection. Okay? Cool thing. A collection is just a collection of documents. You don't need to define a structure. You don't really need to know anything in advance. So what happens is, if you just say, hey, fetch the employees collection for me, right? If it doesn't exist, it'll just make it. So by fetching it, you can also create it. So you don't really care if it already exists or not, it'll just work. Damn it. Oh my god, I am bad at typing blind. Ah. Sorry guys. There we go. So far so good? Give everyone a minute to type. We're going to go a little bit over time, guys. I'm sorry. It's not going to be too much, though. Okay, looks like people are caught up. So now, let's go ahead and we want to make an index on here, okay? So I'm just going through all the stuff you would want to do. Let's go ahead and create an employees index, right? Or an index on the employees collection. I thought I turned it off. Okay, anyway. But this seems very similar to what we did in the UI, right? It's basically the same thing in code. I'm just getting you guys familiar with the interface here. Okay? Good. So now, let's create another index, because when we search for employees, we also want to search for them by a department, right? So we can do this kind of thing. Now notice, I needed to put the key in quotes because of that period. Otherwise, JavaScript does not like it. Get over here. Yeah, we're almost done. There's not too much left. Oh. Yeah, it's fine.
Is that one used to refer to an index?
That's used to refer to an ascending index. One is ascending, negative one is descending. That's a little bit annoying. I feel like it should be an enumeration, but whatever.
Why do you use for department.name, but you don't use it for name?
I did. Oh, the quotes?
Yeah.
Because there's a period.
Yeah, it's a JavaScript thing.
Yeah.
So if you take out the period, it will error out.
Yeah. Cool. Ah, okay.
Have you had Korean breaking JavaScript a lot as well?
Oh, I never wrote Korean inside like JavaScript.
All right, so next, I'm sorry, time. So now, let's go ahead and actually make an employee, okay? So let's make a document. We're going to call him Bob employee. Bob is going to be our buddy. Now, earlier when we inserted that new department, we did not specify an index. It created an index for us. But you can specify an index. So let's go ahead and do that. I'm going to do ID, new object ID. Typing blind here. Yep, good. Okay. And then we're going to do name, Bob Smith.
We need to import new or like object ID.
I think it does it automatically. Yeah, it did it automatically.
Oh,
Yeah. And then we can go ahead and here comes the heresy, Tom. Are you ready? Some good old-fashioned heresy. ID, marketing ID, which we grabbed earlier when we inserted our marketing thing.
Just like Beege. Oh, that's the heresy.
That's the heresy.
So if it was just ID, it wouldn't be that bad because it would serve as an index.
Yep. But no, we're indexing the department name. We're not even indexing the ID. We're actually only putting the ID in here because later, if a user wants to look at the department specifically, then they can look up the department by ID, which would be faster. But they don't necessarily have to. The index is fine too. You could do this without storing the ID in the employee.
So it's like an escape hatch.
Yeah.
Does
But
it suggest that if you have to do lookup, something went wrong during the design phase?
yeah. Now you don't necessarily need to, but I like to. It's a personal preference because I'm paranoid. So everyone's got this? Does everyone understand what heresy we're doing here? Heresy in relational land. But in MongoDB land, this is right and good and proper. Okay? So now, let's go ahead and let's do it. Let's insert Bob. You're going in, Bob. Or, oh, we should have called him Major Tom. Ground control to Major Tom.
Your extension got in your head.
My extension got in my head?
Because MetaBob.
Ah, MetaBob.
Yeah.
Yeah.
Think about Bob, and so you named the employee Bob.
Yep. All right, now, so that's all good and well. But when we do something like this, right, maybe we also want to, now this is just a toy example, right, but this could be usable. Kind of, not really. You'd want to obviously abstract it out for API calls or whatever. But, actually, maybe we could just stop there. Oh, no, I wanted to do that. Right. Okay. So that's cool. So now we have Bob, okay? And we have Bob's department stored in Bob. And so that way, when we pull his record, we can see what department he's in. We don't need to make any additional queries, okay? We find Bob, we can see his department, done. This is the MongoDB way, okay? But let's say that we also want it to work the other way around, okay? Maybe we want to be able to search for departments based on their employees, right? Duplicate the data. Who cares? Duplicate all the data. Heresy. So what we can do is we can basically, and this is where we get into kind of changing the structure of the document to fit our use case. We can do on our departments, right? We know that no departments currently have members, okay? This would be something that you would do in like a database migration file, okay? Actually, a lot of this is. But we could say we can update many of our departments, all right? Now, when we do update many, it takes in two main arguments, okay? The first is your filter. Because remember, in MongoDB land, filtering is first. Everything else comes afterwards, okay? So our filter first, which documents do we want to update? In this case, we want to update every document in the collection. So we just say empty document, okay? And then, what change do we want to make? Now, this is where updates get a little bit weird, okay? There are multiple ways you can do updates. For example, let's say the field you wanted to update was an array, okay? And you don't want to change the existing contents of the array. Maybe you want to add something else on. You could use the push operator, right? But let's say you just want to set some key equal to some value. You can use the set operator, okay? So we could do this. Yeah, so we're going to do set. I'm going to say all departments should have a member's key that has an array as its value. Okay? So far, so good? Cool. Oh, that was bad. That was a mistake. I'll fix that later. Okay. So now, what are you doing?
Because MetaBob needs to we have to shut down Visual Studio Code to reload it.
Screw it. All right. So now all of our documents have this this name index on it. Honestly, I forget if we need to add no, so not all of your documents need the name field, but I had some weird behavior when I did the index afterwards, but I would need to experiment more, and I ran out of time. So let's go ahead and add our index on here, or we can say members dot, we want an index on members.name. Now, basically, you might be wondering, like, Beege, what the hell are we doing and why? I'm just demonstrating all the stuff you can do, okay? So in this case, members on our departments is going to be an array, right? We see this here. But we can set an index on a nested field of that array. But Beege, there is no field. It's an array. We're assuming that this array will have objects that have a name field in it. And that just works, okay? And what will happen is it'll index that document for all of the names in that array. Does that make sense? So that's pretty cool. So now, let's go ahead. So we have Bob in his marketing department. Bob is storing his marketing department, but the marketing department doesn't know about Bob yet, right? So let's fix that. What we can do is we can say in our departments, we can update one department, okay? And in this case, we can search for a department by ID, where the ID is from Bob, his department, and then that department's ID. And so this is going to be like instant, right? Because we're searching by ID. Okay, so this is our filter step. And now, here comes our update step. In our last update, we did a set operation, right? To set some field equal to some value, right? But maybe someone else has already added something to the members array. So what we can do is we can say push. So we can add a value to that members array. And we can say members, wait, hold up. I might not be remembering this properly. Give me a second here.
This implicitly happens to that array, so
I believe so, but let me just double check that I have the syntax right. Aha, I have the syntax wrong. Okay, I'm glad I checked. Give me just a second here. Yeah, okay. So this is wrong, I'm sorry. So to the members array, we're going to push a new object, and that object is going to be, nope, wrong one. There we go. Is going to be a new instance of Bob. Okay? So we're going to say, ID bobemployee.id, and we're going to say name bobemployee.name. Now notice I didn't just insert the whole Bob document. Why? What else is in the Bob document? Department. So I don't want to have the department in the department. That's just unnecessary, right? So you don't want to be like stupid with your duplication. You want to be smart about stuff, okay? So has everyone got this? Cool. So here we have it. Whoa, wrong thing. We have really. What are you complaining? Oh, is it complaining about? Yeah.
You can just reload.
Yeah.
Then it will
Will it?
the reload button.
I think that just reloads the. That's just the. Huh? This.
Control Shift P and
This has reload.
go for reload window. Second.
Oh my God! Thank you so much. Oh, beautiful. Okay. So now, just to review, we inserted a new department. We grabbed that department's ID. We created a new employees collection. We create some indexes on that employees collection. We defined a new employee. We inserted that employee. We made sure that all of our departments have a members array. We created an index on that array. And then we went ahead and basically added Bob as a member of the marketing department by adding him to that members array. Okay? the rest of this stuff, I want to show the output of the department stuff, so we're just going to leave that there. Okay? So now, God, I hope we did this right. Don't run it yet, because if there's a bug, I have to do a whole bunch of cleanup, and I don't want to walk you through all that cleanup because I did this in a very hacky way. So let's see if it goes. Cool.
Pressing enter.
Oh no!
Go prisoner.
Bob did not get pushed. Why did Bob not get pushed?
Did you await?
What's that?
Did you await?
I did not await! Oh! Okay, but, maybe it's okay.
It's there.
Maybe. I'm sorry, guys. Don't make newbie mistakes like me and forget to include your weight. Where's my mouse? Oh my god, no. Oh no, my mouse is gone. Oh god. Okay, there it is.
We can just export standard, right?
Damn it. Okay, guys. I'm gonna clean this up. Oh wait, no. This is employees. No, this is departments. What? Oh, no, this is right. So, I forgot my awaits. Please add the awaits in there. But it's still executed. So, we just didn't wait for the result. But, you see here, we have this ID. God damn it. All right, actually, that's fine. So, we have our new marketing document. We have the name marketing, and we have Bob here as a member. And then, we can search for Bob. So, we can say members dot name, and we can search for Bob Smith. Actually, we don't need, do we need the quotes? Oh no, it has it. Yeah, we can do find. There we go, it matches. And that used the index that we defined, which should be super fast. All good? Cool. Other stuff we could do too, we may want to put a unique index on the department name, because we shouldn't have departments with multiple names. We would not want to put a unique constraint on the employee name, right? Because people can have the same name. But we might want to put a unique constraint on the employee ID of members of a department to prevent the same member from being added to a department twice, in case maybe later we want to check the number of employees in the department, right? So these are various things we could do to improve. But I just kind of wanted to demonstrate different operations you could do in MongoDB, how you go about doing things, how you structure your data, okay? Now, to be very, very clear, this is not a good way to do stuff, right? Your structural changes, like setting a members field on every single document, or adding indexes, you would want that to be in a database migration, right? Adding Bob to the employees collection, and then updating the corresponding department document, adding Bob as a member, you would want that as part of an API call, right? But I just wanted to demonstrate just the MongoDB side of things and how you can accomplish certain tasks. All good? Cool. So, to wrap up, first off, do not forget to kill your Docker Compose, okay? If you don't care about the data, go ahead and do Docker Compose down to clean stuff up. If you do want to look at this data later, don't do Docker Compose down. It'll destroy all the data. I did not create a persistent volume because I wanted it to be easy to rebuild stuff. Okay. So, although this should work on a blank database too, so that should be fine. But to recap and then get out of here and get some chicken. So, some quick tips. Oh my God, we're way over. I'm so sorry, guys. If you're doing an aggregation pipeline, which we did not do today, make sure to do your matches early, okay? This you can just reference later, okay? Remember, an aggregation pipeline is a series of steps. I mentioned like the facet stuff. You want to do your matches as early as possible because that limits your data set, making stuff faster. Again, duplication is good, lookup is bad. We already talked about that. There's this nice little trick here. If you have variable fields, right? Like maybe you have count children, maybe you have like count elders, maybe you'll eventually have count women, count men, count married, count whatever, right? Rather than have, adding all these different fields whenever, some documents might get them, some documents might not, you can instead do a kind of inverted structure where you do counts generally, and then you have the children part be a value, right? And that way, if you want to add count seniors, you can do that as another object. If we want to add another thing like count women, count men, we can just add more objects. We don't have to create a new index. We don't have to modify our structure. We're just adding data at that point. All right? So this is a nice pattern to be aware of. And then you index on count.demographic, right? Or maybe count.demographic and count.count. But does that make sense? What's up?
Is it possible to create a running aggregate that keeps track of inserted objects as in, say, summing up a count of seniors or count of children, whatever this is?
Yes, and you actually want to do that. So there may be cases where maybe you want to track the stats of stuff, right? Maybe you're inserting a new person, right? And that person is a child, right? You may not want to necessarily go through and count every child again. You can put an index, do an aggregation pipeline and do that, or you can make a separate collection like statistics and then just have one or two documents in there where you just add one each time you do an insert. That's actually the MongoDB way, okay? Your writes are a little bit more work, but your reads are way faster. So yeah, good insight. Very good point. That's exactly correct. Other questions?
Index counts what you said is automatically counts on demographic.
No, I messed up actually. So index on counts.demographic, and just so that I don't have to do all the formatting stuff again, counts.count in the same index. So in this way, if you put an index on count children, that would just work, right? But instead, you can do a compound index on these two fields and get the same result, where you can track additional demographics without needing to change your index. Because then you just add new data, and then that new data gets indexed. Does that make sense? Cool. Other questions?
Does the cardinality matter here? So in relational databases, the higher cardinality should go first,
Right.
right?
Right.
Because it's faster to look it up.
I don't remember.
Okay.
I think it does. But I don't exactly remember. I would recommend Googling it. I'm sorry. Other questions? Cool. I do remember somewhere in MongoDB, the way that it parses JSON is ordered. So there is somewhere where cardinality matters. I don't remember if it's here or not. Yeah. But yeah. So again, I'm sorry that this was a very contrived example and that it wasn't a perfect fit, but hopefully this gives you a good idea of MongoDB, how to use it, NoSQL databases generally, and how to use those. I'm also very sorry we went over time. But again, we covered what are NoSQL databases, the different types of NoSQL databases, differences between relational and NoSQL databases, and then what are good use cases for them. We went over how MongoDB works generally, again, databases, collections, documents, and indexes, these kinds of things. We went over data modeling a bit. Remember, duplication is good, nesting is good, as long as you don't overdo it. And then we went over querying and aggregations at a high level, and then we did some example queries. We didn't do any aggregations, but maybe in the future if you want. And then we went over just a couple of MongoDB tips and tricks. Now, one thing I do want to cover here, wrong screen. I do recommend looking through the additional resources because we did skip over a lot of stuff, and this gives much more detailed information. Specifically, MongoDB University, they have these online classes for free. They are really good. They are really, really, really good. They're some of the best online classes I've ever taken. So I recommend those if you want to go deeper into MongoDB. But yeah, the video, should have put the URL in here. I'll just put it in later, excuse me. But thank you for coming. I did this from the template. Oops. So if you have any further questions, you can email me here. And if you want to message me on Discord, you can message me here. Sorry about that. But yeah, and if you want to, that QR code right there will take you to our Discord if you're not in there already, or you can just type the address. We are a registered nonprofit. We do accept donations. Our donations are not tax deductible yet. We're working on it. And it's a lot of work and it's actually really expensive, but whatever. But if you want to help offset the cost of things like pizza or the money to incorporate so that we can get tax deductible donations, donations would be appreciated. But if you don't have an income right now, do not donate. Okay? But if you do, we welcome donations. It doesn't need to be anything huge, but every bit helps. So thank you very much, everyone. I apologize we went over time. Let's go have some chicken.
Thank you.